Hi everyone, I'm going to be presenting my capstone project for my degree. So the increasing PM 2.5 amidst increasing wildfire hazards in Richmond, California. Here's the table of contents. And to start, I'm going to go into a little bit about the background. So Richmond, California is a very unique study site as it is the only location in the country that's exposed to both direct oil refinery pollution and heavy wildfire smoke. With increasingly catastrophic fires in California due to climate change, air quality has been a growing topic of concern. But it has yet to be seen what the combined effects of the wildfire smoke and the already present air pollution in cities are. Not to mention the ethnic and economic makeup of the city also creates a strong backdrop for environmental justice as citizens fight for their right to clean air. And speaking of the oil refinery, in 2021 alone, the Chevron in Richmond has emitted over 4.3 million metric tons of carbon dioxide into the surrounding environment, making it the second highest emitter in the state of California and the largest in the city. So that brings us to our problem statement. How might the combined effects of wildfire pollution and ambient air quality impact public health risks in Richmond, California? And so to address this problem, we took this in two different approaches. The first is a qualitative analysis. And in that qualitative analysis, we conducted case studies to try to understand the historical context of Richmond, California. So the second approach is quantitative, where we also took it in a twofold. So the first analysis was done using historical PM 2.5 wildfire data to build a statistical model that will predict the future increase of emissions. And so PM 2.5 refers to particulate matter 2.5, which are tiny particles or droplets in the air that are less than 2.5 microns in width. And this is sort of the fundamental statistic that we're using for this project. The second analysis is done using geospatial data. So data put onto a spatial scale to sort of understand and highlight where people are most affected by this combination of refinery pollution and its wildfire emissions. So looking at the results, to start, our statistical models. So we use the linear regression formula, y equals ax plus b. It's a pretty common formula everywhere. And so we essentially plugged in a bunch of historical wildfire data and generated this R squared, which helps predict the increase of average extreme PM 2.5 by year. And likewise, so this R squared gets plugged into the A over here, and then it generates this line. Likewise, this next one is the same thing, but by n. And so onto the maps. So through our geospatial analysis, I built out a context map. In the middle, you can see, so this gray outline, I don't know if you can see my mouse, but there's this gray outline that highlights the boundary of the city of Richmond. Over on its right, the red, yellow, orange is the different fire hazard severity zones, and on the left, so that purple object right there is location of the Chevron refinery. So the city of Richmond is bounded by two different air pollution risks. And we wanted to consider demographics when we're looking at this issue. And in this map, I've highlighted the presence of ethnic minorities in the city of Richmond. And you can see that around 80 to 99% of the people living there are ethnic minorities. As well as on the second map, this highlights median household income in the past 12 months for 2020, and the majority of its residents make under 70K a year in total median household income. Now, combining all the factors mentioned previously, such as proximity to the different air pollution sources, as well as demographics, this map displays an analysis of the air pollution risk. And that red circle in the middle right there is where we believe that the most people are going to be affected by this combined air pollutants. So the conclusion for our project was pretty simple, mostly just that air pollution is only going to get worse due to wildfires, from climate change, as well as the Chevron refinery not closing down anytime soon. Not to mention that the risk in air pollution will be disproportionately affecting low-income and minority households most, because they are forced to live in those areas because of cheaper rent, cheaper housing as well. So that concludes my presentation. Any questions?